this section, we're also going to discuss how to graph a piecewise defined function. And a piecewise defined function is a function comprised of two or more functions, each with restricted domains. So an example of one, f of x is equal to, and here you can see this brace on the left-hand side, and the first function is x plus 1 when x is less than 0. And then the second function is negative 2x when x is greater than or equal to 0. So we can tell that these are both lines, and if I drew both lines fully on the same grid, we would not have a function because it would not pass the vertical line test. But if I restrict their domains as described, then we would hopefully have a function. Okay, so the first thing that I'll do is take a look at this value. It's kind of like a transition point of the graph, and it's found just in the domain or domains that are given. In this case, 0 matches, but whatever it is, I want to kind of draw a vertical line at that location. Okay, next, the first function, y equals x plus 1, is going to be drawn when x is less than 0, or to the left of this vertical line in region 1. And then we're going to draw the second line, negative 2x, when x is greater than or equal to 0, and that'll be on the right side of the vertical line, so in region 2. And how we can draw these lines pretty quickly is to use their slope and y-intercepts. Okay, so the first line, y equals x plus 1, the slope is 1, the coefficient of x, and the y-intercept, b, is also 1. It's the constant. Okay, and so I would go to my graph and I would draw a point at the y-intercept, which is at 1, and then the slope is 1. So if we think about it as a ratio 1 over 1, we would go up 1 and right 1 and place another point. Because I want to draw the graph to the left of the y-axis, we're going to go down 1 and left 1 instead. Okay, and then sketch this ray that passes through the points that you have drawn. Okay, now we're going to sketch the line y equals negative 2x. And this line has a slope of negative 2 and a y-intercept of 0. Okay, so at the origin, we'll put a point, and if the slope is negative 2, we will write it as a ratio negative 2 over 1, and from the y-intercept, count down 2 spaces, write 1, and then another time as needed. And then we'll draw the ray through these points. And lastly, on this vertical line that we started with, that there is at most only one point, and so we have to decide where, if at all, that there is a point. Okay, so we take a look at the given domains one more time. When x is less than 0, we drew the line y equals x plus 1. So not when x is equal to 0. So on that initial line, we need an open circle for that end point. But on the second line, y equals negative 2x, we did draw that line when x is greater than or equal to 0. And since it said that 0 is an x value on this piece of the function, we want to ensure that that point is shaded in. And now this function does pass the vertical line test. And lastly, if we're asked to write the domain of the entire function, we can look at one of two things. We can refer back to the restricted domains that were given, and we see that all real numbers were accounted for. Okay, so the domain is from negative infinity to infinity. And the other option is to look at the graph and go from left to right and ensure that your hand or ruler passes through a point in all places, which it does. and therefore we would say the domain is all real numbers.